Good afternoon, Minneapolis. Welcome back to Ocean 101. Today's topic is hydrothermal vents. So let's get started right at the beginning. In 1977, Bob Ballard and a team of scientists first discovered hydrothermal vents while exploring an oceanic spreading ridge near the Galapagos Islands. Hydrothermal vents are like hot springs on the ocean floor. They are commonly found near volcanically active places, areas where tectonic plates are moving apart, ocean basins, and hotspots. At hydrothermal vents, magma rises and heats circulating seawater deep in the ocean's crust. This hot, mineral-rich water exits the oceanic crust and then mixes with the cool seawater outside the vent. To speak to his knowledge on the various types of hydrothermal vents, we have on the line researcher Garrett. How are you doing today, Dr. Geyser?
Hi Isa, I'm doing good. So to start off, there are two main types of hydrothermal vents, black smokers and white smokers. Black smokers emit the hottest, darkest plumes and can form chimneys up to 55 meters tall. In black smokers, the smoke is actually caused by the presence of iron and sulfur, which can combine to form a black iron monosulfide. White smokers release cooler plumes and their vents contain more barium, calcium, and silicon.
It's really interesting. So if the magma under the ocean floor is heating these elements, how hot is the smoke that is coming out of the vents?
It's a great question, Isa. The seawater in hydrothermal vents can actually reach temperatures of over 700 degrees Fahrenheit. However, hot seawater in hydrothermal vents does not boil because of the extreme pressure at these depths where the vents are formed. At sea level, the pressure equals 1 atmosphere, or 14.69 pounds per square inch. But then, for every 10 meters you dive, the pressure increases by 1 atmosphere, in turn increasing the boiling point for water. No problem. Have a great day.
Instead of photosynthesis, organisms at hydrothermal vents use chemosynthesis. The water from the hydrothermal vent is rich in dissolved minerals and supports a large population of chemoautotrophic bacteria. These bacteria use sulfur compounds, specifically hydrogen sulfide, a chemical highly toxic to most known organisms, to produce organic material through the process of chemosynthesis. These microbes get their energy from the different chemicals in the hydrothermal fluid, rather than from the sunlight. This showed scientists that life can exist without the presence of light. So overall, hydrothermal vents provide nutrients that are essential to deep sea life and ocean chemistry. The discovery and continual research of these hydrothermal vents has given rise to many biological theories that have shaped and will continue to shape the science of oceanography. Thanks for tuning in to Ocean 101. Have a great day, oceanographers.